We're talking now about domains and how we can use inequalities to find domains. This was supposed to be part of the previous lecture, so I didn't want to waste another piece of paper. I put the title on this side here. So this is still objective 1.6.1, which is solving inequalities, but we have sort of an application of solving the inequalities here, which is finding domains of square root functions. When we did domains of rational functions with numerator and denominator, we couldn't have a zero in the bottom of the function. That's what would cause us a problem. Here, we can't have a negative number under a square root, right? If you try taking the square root of a negative number, until we get to another chapter, you will get an error in your calculator. So we can't do the square root of positive number. I'm sorry, we can't do the square root of negative numbers. We need to make sure that whatever is under the radical is a positive number. So here we need for x minus 7 to be greater than or equal to 0. I'm sorry, I misspoke. Actually, we need to make sure this is a non-negative number. It's okay if it's equal to 0. So it's got to be positive, greater than 0, or equal to 0. And then we solve that just like any old inequality. X is greater than or equal to 7, which means that our domain is any number 7 to infinity. Right? Any number that's greater than 7, and you can do that in the number line if you want, right? From 7 greater than would be from 7 to infinity, and that might help you thinking about doing this interval notation. The interval notation is what MyMathLab is going to want, and it is an objective of this course. So you want to make sure you know how to do that. And I want to show you how to check this in your calculator. Okay. Put the function into the calculator. We have h of x is the square root of x minus 7. So the square root is right there, x minus 7, and then close the parenthesis to show that that's the end of what's under the radical. And then when we go to graph, we see that our graph starts on the x-axis at 7 and goes that way. There's no graph down here. Graph starts at 7, goes that way. We can also check our table, and we should get error for everything except at 7 we should start getting numeric answers, and everything greater than 7 will also give us a numeric answer. Okay, so your calculator can be a little bit helpful here. Couple more. Right, the domain here, the thing that's under the square root is what has to be non-negative. So the 2 doesn't matter at all to the universe here. We need 1 minus 5x to be greater than or equal to 0. I'm going to move that 1 over to the other side. 5x is greater than or equal to negative 1. And then divide both sides by negative 5. And when we divide both sides by a negative, remember we have to flip that sign. And negative 1 divided by negative 5 is 1/5. So any number less than or equal to 1/5 here is in the domain of the function. So our domain is going to be from negative infinity up to and including 1/5. So a bracket at 1/5. One more, just to illustrate something a little bit different. Here we've got g of x is equal to 5 over the square root of 4 plus x. We still need what's under the radical, right? We still need our 4 plus x to be greater than or equal to 0. But since this is in the denominator of the fraction, it's not allowed to be 0. So instead of having a greater than or equal to here, sorry, I made a 5, should be a 0. Instead of having a greater than or equal to, we have a strictly greater than, and we subtract 4 from both sides, and we get that x is greater than negative 4. So from negative 4 to infinity would be our domain. And let's check that in the calculator. Let's put in 5 divided by the square root of 4 plus x. And what we should get is a graph that starts at an x-coordinate of negative 4 and goes to infinity. And that is what we get there. You can use trace, and you'll see our x-coordinates are fine until we get to negative 4. Sorry. we keep getting y values until we get past -4 and it stops. So there is no graph to the left of -4, it's all to the right. So from -4 to infinity. Right? So that's finding domains using inequalities.